increases the nuclear charge. And we already saw that if the nuclear charge is greater, then the attraction for the electrons is also greater, meaning that they will all come closer towards the nucleus, giving us a smaller atomic radius. So the atomic radius decreases across the period due to the addition of an extra electron in the outermost shell, which brings about the addition of a proton to the nucleus, and this increases the nuclear charge. After increasing the nuclear charge, automatically that will bring about a decrease in the atomic radius. That is across the period. Let's take an example of the variation. Example of period variation in period 3. So we are going to have the element and the atomic radius in nanometers. And nanometers, those are measurements of length. 1 nanometer is equal to 10 power negative 9 meters. 1 from nanometer to meters, that is the conversion. So in period 3, which elements do we have? We have the likes of sodium, we have magnesium, we have aluminium, from aluminium we go to what we call silicon. Then we go to P. May all sleep peacefully. Since sulfur children are, we are going to stop on argon. In period 3, remember we have what we call the short period and the long period. The short period, that is where we have 8 elements, about 8. And then in the long period, that is where we have about 10 elements. That is in the transitional part. So we have sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and then Ar is argon. We have sodium being at 0.156 as the atomic radius, magnesium being at 0.136 as the atomic radius, aluminium being at 0.125 as the atomic radius, silicon being at 0.117. We have phosphorus at 0.110. Then we have 0.104, we have 0.09, and 0.094. This is the variation of atomic radius across the period. And we say that across the period, the atomic radius decreases And that is because as a result of addition of an electron, you can see as I showed you 11, 12, 13, 14, 15, 16, 17, 18. So that kind of electron that we go adding in, we add an electron because we want our element to remain neutral. We have to automatically add a proton. And we are having the first element in the period 3, having the atomic radius of 0.156. Magnesium, the second one, having 0.13. So from here to here, there is an addition of an electron. We have plus one electron. From here to here, we have plus one electron. Even here, plus one electron, plus one electron, plus one electron, and plus one electron. So when we start with sodium, you realize that the atomic radius of sodium is 0.156 nanometers. As we add an electron and come to magnesium, which has 12 protons and 12 electrons, you find that its atomic radius has reduced to 0.136. Aluminium 0.123. Silicon 0.117. Phosphorus 0.110. Silicon 0.104. Chlorine 0.09. And finally argon with 0.094. From even the visual trend, you can see that we are having a decrease in the trend across the period, which satisfied that as we move across the period, the atomic radius decreases as a result of addition of an extra electron, which brings about addition of an extra proton, thereby increasing the nuclear charge of the nucleus, which increases the nuclear attraction of the electrons in the shells, thereby reducing on the atomic radius. And in most cases, we can tell you that plot this one on a graph. It is always plotted the atomic radius against the electronic configuration or atomic number. So I find sodium has 11, 12, 13, 14, 15, 16, 17, 18. So you plot 11 against this against this against this, and you obtain a graph that is in kind of this shape that shows the decrease in the atomic radius. So in case you're faced with a question and it's talking about atomic radius and it requires you to plot a graph, that should not be something new. You can try it in your free time. You try to plot the atomic radius against the electron configuration, or what we call the atomic number.